Hello everyone. Before we start, I would like to repeat some announcements. Please don't forget to rate sessions at schedule.com. Please enter, and when entering or leaving the room during the session, please try to not make a lot of noise, and try to hold the doors. Also, when you are asking questions, please ask them loudly, because we don't have a mic for the audience. Don't forget to join Sunday's closing session. You can win great prizes there. And don't forget that after the last session today, there will be a special event. Don't go anywhere. Don't go for a beer yet, but wait outside near the fountain, and there'll be special surprise. Also, it seems that this talk is quite popular, so if you can squeeze a little bit into the middle to make some room for people that might come during the session, that would be perfect. Don't be shy.
Hello? Okay. All right. Yeah.
So we have our next speaker, and we will be fixing the internet with Martin Bähr.
Okay. Wow. I didn't expect such a big outcome. So you all agree that the internet is broken and we need to fix it? Yeah? Is that it? Okay, so let me get started. Let me say I'm a little bit nervous, because this is the first time I'm giving this talk in such a big audience. I've given the talk before in front of like 5 people, and I realized that I was like, oh my God, it was really terrible, and I had to redo it. Help me out, please. And one thing I do like questions. So if you have any questions, we don't need to wait with the questions to the end. If you have any questions, feel free to interrupt me. We can discuss questions as we go along, if you have something to the point that I'm talking about. So my name is Martin Bähr. I am originally from Austria, and I live in China since almost 10 years now. And I am the development community manager for Elastos, which is the project I'm presenting. So I joined the project in October last year. So I'm actually very new in the project. And my job is to make this project interesting for developers and for programmers. So let me start with talking about a little bit about the state of the network, the state of the internet. You all work with the internet, so I think you will understand what I'm talking about. If you think back about the history, how the internet was developed, how the first computers got on the network, on the DARPA network. Basically, at that time, the internet was built on trust. And it was assumed that all the computers that are on the network are trustworthy, that we know who the administrators are, that you can trust everybody who is on there, and that basically the network is safe and there are no bad people on the network. And the result of that today is that the internet protocols that were developed, they were all developed with this trust in mind, And what we get now is that it's now difficult, because of that, to keep bad people out of the network. We get spam, yeah? We get denial of service attacks. We got problems with cookies. Cookies are really bad. That's an interesting story. I mean, cookies are so bad that the European Union has made laws to protect the average people from cookies. Think about that. We're technical people. We're designing this stuff, and we produce something that is so bad that we need lawyers to protect people from what we did. Yeah, this shouldn't have happened. We should have been able to do a better way. And then comes Internet of Things, and it made everything worse, because pretty much all Internet of Things devices, they're hopelessly insecure. There is no safety, security, there's no protection on these devices. They can easily be hacked, they can do everything they want. And really, if we want to have a safe network, we kind of want to block IoT devices from accessing the internet, because it's the only way to get security and safety, is to just not let those devices onto the internet. Yeah, I mean, there are lots of challenges with IoT security. They're embedded in real time, and they're small, distributed, decentralized, so it's really hard to control what's happening with IoT devices. So how do we get out of this mess? One observation I made is that conceptually, ideally, we think that making small changes, or making changes in small steps, is a better way to achieve something. Who here would tend to agree with that? You think it's better to make a big, drastic change, or to make small, incremental changes? Small. See, it's logical. It makes sense to make small changes. But look at IPv6. IPv6 is a small change over IPv4. Yeah? It's a small change because all it does is it's making the address space bigger.
It's not.
Yeah, okay, all right. Well, I think it's a small change. And, but it's a very expensive change. It's a very difficult change to actually implement. It doesn't. The point, why I'm saying it's a small change is because for the end user, IPv6 doesn't really change much. It doesn't really add as much other than give us a bigger address space. It doesn't really add much more. So that's why it's a small change. But it's a very, very, very expensive change to implement, and so we still don't have it. It's like, what, we're waiting 15 years, 20 years now? On the other hand, we've got big disruptive changes that were adapted very quickly. Twitter or Facebook or the web itself, HTTP, web browsing, yeah, basically it changed from the day it was invented. It changed the way we did things in a drastic way, and it was very quickly adapted. So Elastos is an operating system that is disruptive. It completely changes everything the way we're doing things. But it's easy as getting into getting a web browser, and so it will be an easy change to implement, if you like to implement it. All right. Excuse me, I can use this one, yeah? Let's take a closer look at what Elastos actually is. It starts out with it's a runtime. It's a complete set of C++ APIs and frameworks, a distributed operating system runtime with end-to-end security across the network. It's designed for containers, for virtual machines, for IoT devices, and it uses blockchain for authentication. I'm going to talk about each of these points in more detail. the C++ APIs and frameworks. So basically, what Elastos is achieving is sandboxing applications at the C level. Compare that to Java. In Java, you have a kind of sandbox, but if you want to do stuff on the C level, you're breaking out of that sandbox, and you're no longer in the Java sandbox. And so the protections that Java applications have no longer apply when you use a C library. So that's something that Elastos is fixing. We built a runtime introspection system to allow to build dynamic applications. This is a very programmer-centric detail. I can talk about that if there's interest, but I don't want to go into detail with that. And the last thing is Elastos rewrote the complete Android stack in C++. Okay, think about this one. Do you know how big Android is? 10 million lines of code or so. They rewrote the whole thing in C++. Yeah, I joined this project a few months ago, and I found out about that, and I was like, wow, these guys are either crazy, insane, or they're genius. Yes?
How much faster it got when they rewrote it?
You want a number? I don't have numbers. The question was how much faster will it run? Okay, so why did they do that? Performance and footprint. So yes, it's faster. I don't have any numbers. That's a topic for another talk to actually analyze how much faster it really is. But there are more advantages. One is you can write C++ applications using an Android development style. So because you have all the Android libraries and all the functions that Android has, and you can do the same thing then in C++. And you can port applications from Android to Elastos more easily. So, second point, a distributed operating system runtime. So basically, Elastos is providing end-to-end security and integrity across the internet. It's prohibiting applications from accessing the internet and receiving and sending network packets directly because the network connection is controlled by the operating system. So that's an important point. Elastos is preventing applications from making their own network connections. Who here is familiar with the OSI Network, how you call it? The OSI model, right? The OSI Network Model. Yeah, are you all familiar with that? Most are. Okay, so I'm just going to quickly reiterate. The key point about the network model is that there are basically three layers. There's a hardware layer, essentially. There's the network layer, which is mostly in the kernel. And then we have the transport layer, session layer, presentation layer, and application layer. And actually, all of this here is the domain of an application. So when you write applications, you're in control of all of that. An important aspect here is that end-user identification is part of your application. Think about SMTP again, email. Where does the user identification actually happen? It happens in your mail client. When you sign your mail with a cryptographic key, the mail server has no clue about that key. It will have to accept any email, whether it has a key or not, whether it's signed or not. And only at the end user level in the application, I decide whether this email is genuine or not. The server doesn't know anything about that. The transport layer doesn't know anything about that. And there's no control except for the end user. The same with SSH. SSH has its own idea who the users on the computer are. It's now, by default, using the system users, but it doesn't have to. It could use its own user database, and it would still work. So any program can start a server on a computer, run the SSH protocol, and do its own user authentication and have its own idea who the users are. It's part of the application. Yeah? So identification happens in the application layer. And every application is responsible for its own user identification. And that's why we have spam. That's why spam is possible. Because we have no infrastructure in place that could prevent spam at the network level. There's no way, because the network level has no idea of what's actually going over the network. Yeah? The same with denial of service attacks. Anybody can send any packet to anywhere. And there's no way for any router to know which packets are legitimate and which are not. Because it's in the application layer. The application is the one that decides, not the router, not the network. And Elastos is fixing that. So this is how the same thing looks with Elastos. Elastos is basically taking over all of these layers. It's moving the user identification. It's taking away the user identification from the applications. So what happens now is an application, when it wants to send a message to another person, it makes a request to the operating system. I want to send a message to this identity, which is represented through some cryptographic key or whatever. And then the operating system is going on the network. It's finding where is this identity. And then it's talking to that server or that computer. And then it's asking that question. Here I have this identity who wants to send a message to that identity that you have on your machine there, and is that okay? And ask for permission, and then it establishes the connection. And once that is done, the application then gets a feedback. It's all right, I found the person you're looking for. Here's a socket where you can send your message. And then it can send the message and solve the problem. So that prevents spam. It prevents denial of service attacks, worms, viruses, pretty much everything. No, it's no longer possible because the operating system controls what goes over the network. Yeah? And identities that previously were on an application level are now replaced with global identities at the operating system level. Yes?
Global to the computer or global to the world?
Global to the computer or global to the world? I would global to the network. So I mean, if you have a network that is disconnected from any other networks, then it could be global to the world if you use the same database on two different networks, but it wouldn't have to be. It's global to the network, basically, where all these devices are connected. How much time we have? Still have lots of time, yeah.
How different it is from the web? I mean, why should I use this on web? Web application firewall.
Sorry, say again?
How different it is from the web application firewall? Why should I use this?
Okay, how different is it from the web application firewall? Again, the key point is that the firewall doesn't really know anything about user identities. Yeah? So the firewall can only identify certain bad packets, but it cannot identify people. And so it cannot really verify that those connections are by people that are trusted or not.
Based on the diagram, how do you prevent the app to bypass the Elastos and to go directly to the lower layers?
Okay, how do you prevent bypassing the Elastos runtime? That's a good question. That's a very technical question. Basically, it works by having the applications be built on top of that runtime, and they have to go through the runtime to make the connections. Unfortunately, I don't really know the details on that either. That's actually a question I asked the developers. So how do you actually do it? And are you able to really secure any kind of binary against that, and the answer was a yes or no, and I'm still working on that one, figuring out what's actually the deal here is.
Like it has to be built this way for it to work. You cannot do it.
So yes, my present understanding is that you have to build the applications on top of the Elastos runtime, but I'm hearing voices from the developers that it should be possible to protect existing binaries as well, but I'm not really sure about that one. I think it's more that you build applications that you trust. But that's another thing where I'll talk about that in a moment, where the blockchain comes in. You can put the trusted applications and secure them with the blockchain so that you know that this is actually a trusted application and you can trust the code.
Maybe second thing, if they are on global network, how do you prevent or secure from others who are not using the Elastos? Because you cannot expect everybody on the network will have this runtime.
That's an interesting question. How do you prevent other actors that are not running Elastos from connecting to the network? I haven't actually thought about that question, so I cannot really give you a good answer. A quick answer that just pops to my mind is that you can identify very early whether the connection is coming from an Elastos system or not, because the protocol to connect and to establish is very different. I could probably block any other kind of network connections. So that still doesn't help with denial of service attacks at the router level, because the router still have to connect those unless we are able to add something into the protocol to make routers be able to detect Elastos. So yeah, that's a problem, but I think that's a transitional problem. And which is the goal, we can replace all the network with Elastos, then we would solve that problem.
How do you stop DOS attacks? Because someone has to stop the request, even before it goes to the application, to the web server. Someone has to reject the request anyway.
How do you stop DOS attacks? So we cannot stop DOS attacks from machines that are not running Elastos, but we can stop DOS attacks from within. So a machine that is running Elastos will no longer be capable of doing DOS attacks.
So it's related to the previous one?
Yes.
So we would need to use Elastos to be able to communicate, right? Because then other resources we do not upload which are not based on the Elastos, right?
Essentially, yes. We need to use Elastos to be able to communicate. Yes. So, well, one of the things that one of the ideas here is Elastos essentially is proving a point. It's proving a point that by moving the user identification away from the applications, we get a more secure internet. And the long-term goal would be to actually move these things into the kernel. Yes, it's an adoption problem. All the problems we got lots of different applications or solutions that address this problem, and but the thing is, they're all mostly, as far as the ones that come to mind when you say that they're mostly just applications solving a specific problem set. They're not solving a general purpose computing. And so there are applications that you use in a specific setting. Like I was thinking of Lotus Notes, for example. Yeah, it's one of those which is completely changing how you communicate, and it's replacing everything with its own way of sharing data and then sending messages. And within Lotus Notes, it works in a similar way, but it's a very specific approach, and it's not open source, it's not free software, so not everybody can adapt it. That's the thing. There's no general purpose open source free software solution that would address this problem. And that's where Elastos is essentially, at least as far as I'm aware of, first.
In a case of DDoS attack, well, usually the web application firewalls are, subject to, the capacity of their network, the bandwidth of it. If the DDoS attack is very heavy, like 1 terabyte or something, I need to have that capacity in my infrastructure. Well, does Elastos also fit in that? I mean, is it subject to the same problem also? Or it can mitigate that problem?
Okay, so you're saying that in a case of a denial of service attack, we need to consider the capacity of the network, and the router needs to handle the network capacity in order to respond to all the packets. So, well, the idea of Elastos is we're replacing the operating system, and so all the machines that are running Elastos are no longer a potential source for denial of service attacks. So if I have a network where I'm only running Elastos, denial of service attacks are no longer interesting. They're no longer there. They're no longer happening. So we don't have this issue anymore. And this is a transitional question. It's like, what do we do with a mixed network where we have half of the computers running Elastos and the other half of the computers are running other things, and those other things...
It has to be a trusted network where every network and system is running Elastos, and we can consider all systems there.
All the lines physically protected against attackers.
Okay.
And what if the user modifies his own copy of Elastos?
Okay, I think we're now getting into a very, very detailed questions that we maybe can discuss after the talk. Okay, let's get back a little bit. We still have 20 minutes, so well, let me go back here. Remind you of this. So we said we had a complete set of C++ APIs and frameworks and a distributed OS runtime with end-to-end security across the network. We have Elastos runtime designed for containers and virtual machines, and we're using blockchain for authentication. So we're now getting to point 3, the Elastos runtime designed for virtual machines. So basically what's happening here is, and maybe this addresses one of the questions that was there earlier. It's essentially, you think about it like a C++ virtual machine comparable to a Java virtual machine, but for C++. And so you no longer have what Java has, the Java native interface to write native code, because you're already writing native code inside your virtual machine. And so there's no need to break outside of that sandbox. And you're always staying into the sandbox, and you have basically all the C++ abilities available to write your code. And you can always stay in the sandbox. So essentially, you have all the options. You can still write code in Java. You don't have to write code in C++. You can use scripting languages, or you can use C++ and write native code. You essentially are doing Android-like programming at the C++ level. Now, last point, the blockchain. So the blockchain is doing a number of things. The most important one is to authenticate user IDs. So we're putting all the user IDs on the blockchain to have a global user database, essentially. We're also putting application IDs on there and machine IDs so that you can verify and check who is talking to you, who is on the network. And you can implement applications that use the blockchain. So there's an infrastructure to write blockchain applications. There's support for digital asset management. That's another topic in itself. Why do we need digital asset management? I'm happy to elaborate on that if there's interest, but I didn't prepare a slide for that. And then there are tokens or coins to enable trading of apps and digital assets. The one thing to say that the blockchain part is actually very new. If you look at the history of Elastos, actually Elastos started in the year 2000 as a smartphone operating system, and it eventually lost the race against Android and iOS. It was restarted in 2012 to add this IoT focus, and they reached a beta status. And then last year, the blockchain was added as a solution for the network identification and other things. So here's some pictures of devices that they managed to build and managed to get Elastos running on. So I actually have that phone. Oops, sorry. Here. This phone here. Where is it? I don't see. Oh, there. I've got that phone in my pocket. If anybody wants to see that, I have a phone that's running Elastos. If you come down, you can show it to you. So that happened, and then here's a little bit of an overview of how the things fit together. So basically, there are three different kinds of applications that we see in the Elastos ecosystem, which is personal clouds, portals, websites, application services, and social groups, and basically social networks. And the platform itself is the runtime. The network, so I forgot about that. The network is essentially a peer-to-peer network, so that when an application wants to make a connection to another user or another identity, then it will use a peer-to-peer network approach to find that other identity. And so you no longer are dealing with IP addresses or DNS or host names. You're just, as an application, all you have is an identity. This is the identity that they want you to send your message to. And then the operating system takes care of finding where this identity is using a peer-to-peer network. And then it will send your message across the network once it found that identity. And the third part is the blockchain. And it's running on smart terminals, IoT gateways, IoT devices, sensors, and desktop computers, routers, everything. That's pretty much it. Any more questions? Yes?
Maybe it's not a question, maybe more a statement. You mentioned that basically internet is broken as it is. So maybe Elastos is not a way to fix the internet, it's something similar, for example, like Tor or IoT. So maybe the position of this product would be slightly different. Because it's true that IoT devices are not very well secured. There is missing some kind of application or some kind of framework for the application. So it might be a good idea to use something for that purpose. Fixing everything, I'm not really sure how you prevent spam. I need to admit. I'm not sure what kind of identity management is in there to make sure that
Okay. Let me try to repeat that. So you're sorry, you've been talking so long. I forgot the beginning of what you said. Can you the first sentence? What you said was what?
maybe Elastos is something like Tor for IoT devices.
Okay, so let me try to summarize. So basically, you're saying that Elastos looks like something that is specifically for IoT devices. That's potentially true, but the IoT devices are not the only thing that are on the network. So and there's no reason to stop there. There's a heavy focus on IoT devices because the IoT devices are the most in need of having this problem solved, and so that's why we start there. And they also have the performance issues for the most part. They have more interest in getting something that is actually capable of running on a device that has a few resources. So that is true, but there's no reason to stop there. And you also said you don't really know how this prevents spam. Think about how spam works. Spam works by faking identities, by pretending that a message is coming from someone that it isn't. And by taking advantage of the fact that as a recipient, I need to accept every message because I have no way of weeding out bad messages without looking at them. And by forcing applications to specify which identity they're actually wanting to connect to, I prevent spam. Yes?
So when I want to add, like myself as a new user, so it's used blockchain used for that, for like checking or for verifying our authentication of users. So when I join the network with like new computer or new user, I have to somehow add myself to the blockchain, right?
Yes. Hold on. Let me repeat that. So basically you're saying that when you're adding yourself with your computer to the network, you have to add your identity onto the network, onto the blockchain. Yes, that is true. That is still in development. So I haven't been. I'm not actually working on the development myself. So I don't have an answer to that question.
Because my obvious second question is what prevents me to add like many different identities and using that for those and spam.
So your second question is what prevents anybody from adding multiple identities and using that to add spam. So first of all, I don't think that this needs to be prevented. I personally believe that as an individual, I should be allowed to have multiple identities. I have an identity at home, I have an identity at work, I have an identity in the free software open source community, and those are different identities, and they don't necessarily intersect. I share a different kind of things with my family and my friends than I share here or than I share at work. So multiple identities are not the problem. Yeah? The problem is that when you want to send spam, you want to send a message to somebody and get this person to believe that you are in a certain circle of their trust. A coworker, a friend, or a person selling something. But I'm getting a message. I need to believe that this person has a genuine reason to interact with me. Yeah? And with email, normally, I get all these messages, and then I look at each one of them and decide, is this a person I trust, or is this a person I don't trust? And then I throw out all the bad stuff. With Elastos, I make this decision before the message comes in. I get a
Elastos will not accept any email from unknown person.
Yes, pretty much. But with SMTP, that doesn't work.
Yes.
Yeah?
But that was my first question. How can I join the network if no one trusts me because I'm new?
Well, that's something where we need to work out the protocol how to do that. But this is a problem today. How can I add a trustable SSH key for my SSL key for my server? Even those are not, in my point of view, they're not really trustable because anybody can create an SSL certificate, and then I have to figure out whether I can trust it or not. So this is an unsolved problem. And this is something where it's like we have lots of different solutions that are trying to address this problem. What is like a PGP key signing parties and so on, for example. Trusted signature authorities that have the authority to sign TLS certificates. And all of these are flawed in one way or another, and we still need to work out what is the right solution. But I don't pretend that Elastos has the solution for that. That's something we still need to work out. Yes?
So you showed some devices that you are able to run Elastos on. The question is, like, when you are talking about IoT, there may be some sensors that will not run. Like, I won't run temperature sensor on Raspberry Pi 3 for every sensor because that would be waste of resources, basically, and electricity. So what's the lowest specification device you can run Elastos engine or something like that on? Like, can you run on some Arduino or some really like low performance ARM, or what was the lowest specification?
So the question is, what is the lowest specification hardware-wise that can run Elastos? The honest answer is I don't know. The guess that I will be making is anything that can run a Linux kernel would probably be able to run Elastos. But if it's not capable of running a Linux kernel, then that's like too small and too low. Yes?
The question is the compatibility between Linux and all the other operating systems that are outside. I use Linux, but all my family has Windows. And luckily they're not in the same campus. I have the problem with all the applications which are not compatible between them. How will Elastos make this bridge between my applications guide to the Windows applications guide? Because here I see a big issue in also transmitting data.
Okay, so I understand your question. Your question is, what about compatibility between applications from different operating systems? I would say Elastos does not address this problem because it's not the point. The point of Elastos is to replace the existing ecosystem. In the same manner that Android replaces the Windows and Linux ecosystem. We have compatibility problems between Android applications and Linux applications, even though both run the Linux kernel. Yeah. There are a different set of applications. And Elastos, unfortunately, is going to provide yet another world with another set of applications that are going to be compatible within, but not across Elastos to other operating systems. In the same way that Android applications are compatible within, but they're not necessarily compatible across. That's in part a question for the application developers. If I want to have that compatibility, if I want to be able to read legacy document formats or other things, then the application developers need to provide that compatibility. That's not a question for the operating system itself, and that's nothing that the operating system can solve. That's something that is a responsibility for the application developers. Yes? Okay. So you're saying that I'm sorry again. I didn't really understand the question. I understood the first part, but I didn't understand what you're asking. And now, trying to process the question, I forgot what you said. Okay. How do you get anyone actually onto the network, and how do you get anyone actually to use this? It's the same way it happened with Android. You got new devices that solve new problems, and so people will start using them, and then it's a matter of getting picked up. I know this is very hand wavy, but it's like when you asked Android developers before Android came out, how do you get anyone to use this? You're creating a new ecosystem with new applications, and it's not compatible with anything. It's completely new devices. It's the same situation there. It was the same situation there than it's going to be here. And it's a matter of showing that we're actually solving a problem and that people are interested in seeing this problem solved, and then it will be adopted based on that. Yes?
From my perspective, it looks like your Elastos would be working for something like a Tor network. Well, I know there is a dark web on the Tor network, you know, my mother doesn't know, and she doesn't know how to connect it. So she probably doesn't know how to connect to Elastos.
So you're saying that Elastos is providing a new hidden network that people don't know about, and then they will not easily find it. I don't think that, the comparison makes sense on a technical perspective, but the thing with the Tor network is that there is nothing on the Tor network that is interesting enough for the average user. It's a very specialized network, and only very specialized people are using it. The problem of the Tor network is not its accessibility, but it doesn't have that killer application that draws people in to use it. And that's essentially, it's the same with Elastos, that we need to find those killer applications that will draw people in to use it. If we don't find those applications, then yes, then Elastos will suffer the same fate of the Tor network, that most people will not find it and will not be able to adopt it.
Yeah. So what is an ideal use case to adopt Elastos? I mean, what is the potential killer application?
What is an ideal use case for Elastos? What is a potential killer application? Actually, that's the one part that I left out, is the one killer application is digital assets. So let me elaborate a little bit about digital assets. Essentially, we have the problem of distributing content, movies, books, and so on. And previously, this content was distributed on physical media. And so the producers of movies and books, they would print the books, they would put the movies on a DVD, and they would sell them. With electronic distribution, now made it possible that you can copy those books and movies, and you got the problem with what people call piracy. And so the media producers, the authors, are not happy, so they're inventing ways to prevent that. And the world we have today is that you're no longer buying content, you're renting it. Yeah? You get a lease on watching a movie, you get a lease on reading a book, and when Amazon decides that you should no longer have that book, it will delete it from your device. That happened, yeah? With digital assets on the blockchain, so we're using the blockchain to protect digital assets. We're solving this problem. You can put a set of digital data, a movie or book or whatever it is, onto the blockchain, and then basically the blockchain knows who is the owner of this piece of digital content. And when you want to share it, you don't copy it. You can basically pass it on to somebody else, and you use the permission to use it yourself. You can trade digital assets like you can trade physical books. And so we're solving the content distribution problem by essentially creating a kind of scarcity in digital assets. I know this goes against the philosophy of the free software and of Richard Stallman, but it is kind of a middle ground between we share everything or everything is owned by content producers.
How is it different from, say, Ethereum concept or other things which are solving the same thing? Like, what is the value of the Elastos things beneath it?
Okay, how is it different from Ethereum and other solutions in this space? The big difference is that Ethereum and other solutions, they are pure blockchain, and the only kind of applications that you write on top of Ethereum are blockchain applications. Elastos is using the blockchain, but it's not built exclusively on the blockchain. The blockchain is just a part of the whole Elastos runtime ecosystem. You can run and build applications that have nothing to do with blockchain and that run on top of Elastos. So it's a broader. It basically runs on devices. You wouldn't run Ethereum on a phone, yeah? But you can run Elastos on a phone because you have all these other applications that you can build on it. All right, we're out of time.
We're out of time. Thank you.
Yeah, thank you. All right.